from minus 3,000 to 0. Surely it should be minus 2,000 to 0.
Yeah, it's just the way the scale is, I think.
It should be.
I think
Because
it's
you've got
Yeah, minus 2,000. Yeah, sorry. What I did, yeah, they should be minus 2,000.
Yeah.
It's not the 3,000 that one. This should be a 2,000. Yeah. 1,000, then you go to the 2,000. Can you draw that, please? Somebody go on the board and draw it for me. Red pen. Must be careful. Look, it's a piece of curve, but that curve should be maximum. First of all, connection. Which way the curve is going to bend. Is it maximum or minimum?
Minimum.
Maximum. Why is it minimum? I said when the A
Oh, it's maximum.
is less than a 0, is always maximum. When the A, what's the A? Coefficient of the highest power. What's the coefficient of the highest power here?
2.
It's not coefficient, it's the coefficient of the highest power. Is
Oh, the
this
coefficient minus 500.
minus 500. Is it less than 0? So
Yes.
the curve is going to be maximum.
Yeah.
Over there, coefficient of the highest power is a minus 500. Again, going to be maximum. So, in order to draw it, nobody interested in it. I can go like this. That's going to be minimum, isn't it?
Yeah.
If I go like that, that's wrong. It's always going to be minimum. Am I right? So what I'm going to do, I have to be maximum. It means the curve comes from somewhere. The piece of the curve. It definitely should go like this. Because this continuation of the curve is going to go like this. We don't have it, obviously, but it would be resembling the maximum. The value in here should be somewhere here. But if you make it minimum, look at that, it go like that. Does it make sense? Okay, for the next one, which is 1 point here, 1 point there, how I'm going to connect them? It should be maximum as well, is it?
Yeah.
So between 2 and 5, don't go out of it. Yes? That's the maximum point. The reflection of that, I have a feeling, gonna cut here and goes here, isn't it? Yes or no?
Yes.
This is a mirror image of that. Okay? But my drawing is not scaled, that's why it doesn't come out nicely. Let's bring it a bit down. Am I right? Yes? And this is the maximum. At what point is it this one? How much is it?
2,500.
2,500. Yeah. Accordingly to here. What would be here?
That's anyway.
This way?
No.
That's obviously not. It must be
Maximum.
symmetrical. Isn't it beautiful? Yes? Which is this mirror image of the other one. I'm just doing it. Okay?
Yeah.
Okay, what did I ask you to find out in the last bit?
The distance you can move supports to keep them equidistant and keep the positive and the negative values of the bending, was it, or shear?
Bending.
The bending, the same, so negative this, same as the positive.
A distance. We don't have a distance, do we? Yes or no? We don't have a distance. We don't know how distance we're going to go. So in order to do so, shall we call the distance d? What's this distance? That's a maximum bending, yes? Am I right?
Yeah.
What's this distance up to here?
2.
2 meters. Shall we call it a d? We don't know.
Yeah.
Yes?
Okay.
We call it a d. And we solve the equation for a d in order to find what is it, minimum distance, isn't it?
Yeah.
Moved. Yeah. How much we can move, which is gonna be same. Am I right?
Mm-hmm.
So basically, the first equation, x should be bigger than 0, less than a d. And for the second situation, x should be bigger than d, less than a 5. Am I right? Because we don't know the distance. So then solve it for this situation. How are we going to solve that? How many equations we have?
4.
Okay. How are we going to solve that? The value of the bending moment should be equal by m. Just think about it. What are we going to do? Okay, the expression for S1. We need to find the d, isn't it?
Yeah.
Yeah.
Okay, let's maximum and minimum bending moment we are looking at it, isn't it? Where is the maximum bending moment occur?
Halfway.
Say it again. Yeah,
Yeah, halfway, 5.
at 5.
Yeah, 5.
I agree with you. I agree with you. Yeah. So in here, we need to do something about these equations and look at the x minus 5,000 minus x minus a d. Think about it. You have to solve something. Look at the greatest positive value of the m occur at the midpoint when the x is equal by 5.
5.
Yes. And what's the equation of the bending moment?
Minus 500 x squared plus 5,000 x minus 10,000.
Minus 500 minus x squared. That's good. Okay.
When x is equal by d, x is equal by d, when the s is equal, we are just dealing with the bending moment. We are not dealing with the shear force, and this is the x squared. So can we say that maximum bending moment occur at the 5,
Yeah.
which is for that distance? How much we can move that in order, the d, in order for the maximum and minimum bending moment doesn't change, become equal, isn't it? So if I was you, instead of the x, we have to find a value. And in order to find the value, what we have to do? And the x is equal by the 5 times 5, 2,500. Let's start with the other one. 500, 100, 1,000. Is it this equation of the bending moment? Is it right? These equations? Can you check this one, please? This is when 2 and 5. Am I right? What did we get earlier? Can you make an equation of bending moment for 2 to 5? What was the equation of bending moment? Have you got the equation of bending moment? Not this form, in the other form.
Oh, 1000x times x over 2 minus 5000x times x minus 2.
How are we making an equation of bending moment? Equation of the bending moment is equal by 4, 5. I put the values here before you putting the values here. Bending moment minus 2,000. Is it minus 2,000 or minus 2,500 we get there?
Minus 2,000. Minus 2,000.
Is it minus 2,000? I
Yeah.
put it up to the minus 2,500.
Oh.
Bending moment newtons in meters. Okay. So if I change it to the D, instead of the X, can you change it to the D? You have to make an equation like this. Another equation this way, between D. And I'm sure equation of bending moment should be equal by, I think we got 5,000, we have it here. If I make the equation of the D 5,000, this is a 2 meters, am I right?
Yes.
So 2 meter less than a D would be a 5,000. So become X minus a D minus 5,000 X squared. That's going to be your equation. Just take it from here. How are we going to fiddle with that? the distance, do you remember when you use a distance x minus something? So in here we call it a d. Use these equations. Like, is there any way we can use when the x is equal by 5, use the x is equal by 5. The greatest bending moment occur when the x is equal by 5. Can I say that?
Yeah.
Okay, so let's go x is equal by 5. If the equation would be like this, how much would it be n for this situation? I mean the equation of the n, not the value of them, because you don't have a d yet.
5,000 times 5 minus d minus 500 times 5 squared.
Yeah, just work it out, please. When the x is equal by 5, when the x is equal by 5, put the x is equal by 5. Solve it in terms of the d. The greatest positive bending moment, the greatest positive moment occur at when the x is equal by 5, which is going to be n is equal, if you put x is equal by 5, I think it become how much would it be?
25,000 minus.
It would be something like this, I think. 5,000 D or 500 D? 5,000. Yes? This is happening for when the maximum bending moment occurs. Maximum bending moment occurs. Or when the maximum bending moment occurs, which is x is equal by 5. You're a minute away to solve it. I mean, it's so close to it. So, this is the equation we done. What's the greatest negative? When is this is for greatest positive? When the greatest negative bending moment occur? What is it?
At 2 and 8.
At
2 and 8.
the greatest negative value will occur at the support. Am I sorry? Am I right? The greatest negative, yes, happening at the support.
Yeah.
And how big is it, this support? I mean, what's the distance?
2.
2. So that's for positive. For the negative would be x is equal by 2. Can I say that?
Yeah.
If I put a 2 in here, what would it be? Can I say m is equal by? Put a 2 in here, and solve it, become a, I think become a minus 500. Which is this one you have to use. Hello? You have to use this one, this equation, not this one. This is for 5. I use this one. You have to use this one. Become minus 500, which is x is equal by 2. It happened at 2, but we want to move it. This time we want to move it to what? To d. Put the x is equal by 2. So you have to use this one. That was from the special paper questions. So, the greatest value of the bending moment occur at the midpoint, which is x is equal by 5. The equation become the top one, the black one there. And the greatest negative value of occurs at the support, which is a 2 meter. In here, we're moving the support. We make it as a D. if I move the support, the value of the greatest bending moment is going to still occur at 5, isn't it? Because I said it's not going to change. I'm going to say, how much I'm going to move it this way, which is stay at 5. Okay, so these two equations, can you solve these two equations and find the value of the D for me? These two equations, it's a x at the 5, it gave you the maximum value, but I wanted the minimum value occur at the support as well. In here, minimum value occur at the 2 meters. I want to move it in such a way which is still happening at the support minimum value. Does it make sense? I think so. Okay, can you solve